So what is the B scan, which is the brightness scan? Now remember, at the boundary between two mediums, the ultrasound will be reflected, right? So in an A scan, the pulse that are reflected are seen as actually the amplitudes on the CRO lah. But imagine, instead of plotting the peaks on the CRO, I translate it into brightness of a dot. The bigger the amplitude, the bigger the spot. I mean, the brighter the spot. Understand? So you convert into bright spots. Every peak convert to a spot. The bigger the amplitude, the brighter the spot. Now, for B scan, you will need to have the crystal, which is a piezoelectric crystal. Either one of it swinging very quickly and keep on sending out, or you need an array of crystals. That means you've got many crystals arranged together, sending out simultaneously the ultrasound. As it passes through the boundary of every medium and it gets reflected, you plot all these dots on the computer. So when you have all these dots, which represents the reflection at every boundary, you join the dots together. Remember when you were in kindergarten, you give you the dots, you just join together, you get a picture. So this is what they also do lah. So they join the dots together and give you the image here. So the brightness scan is the one that you will use, that you have seen people doing the scanning the babies inside the mother, right? That one you can see the image of the baby, right? That one is a B scanner. Okay. Now let's talk about why this B scan is not very clear. Have you ever seen the pictures of the? I mean, haven't seen the pictures from the ultrasound scan? Is it very clear? No, right? It's not very clear. It's hard to distinguish one. If they say that's the hand and this the leg, it's hard for you to see. Probably the only thing you can see very clear is the head lah. And there's one part that is even hardest to see. You know what is it? The gender. Okay, it's hard to determine because it's not very clear. So why? We look at the next slide. So let's talk about resolution and attenuation in ultrasound. Now, for you to get a good resolution, that means a very clear image, what you will need is a higher frequency of ultrasound. You know why? The higher the frequency of ultrasound that you use means the wavelength is shorter. Because remember, wavelength is inversely proportional to frequency. So when you have a higher frequency, shorter wavelength, you'll be able to get a higher resolution. People use the analogy, like if your wavelength is shorter, it means like you can paint with a finer brush. But low frequency, long wavelength is like painting with a thicker brush. You cannot draw the finer details. Now, unfortunately, the higher the frequency of the ultrasound, even though it gives you better resolution, the side effect is it tends to be absorbed more by your body. The higher the ultrasound, higher the frequency, the more will be absorbed. That means the higher the attenuation, which is the decrease in intensity. So that means as it passes through your body, more ultrasound is absorbed. And is that good or bad? Which is bad, because we mentioned before, it will cause a large heating effect. Because ultrasound is a vibration of molecules. So when it passes through your body, your atoms will vibrate faster if it's absorbed. And when it vibrates faster, Ke increases, temperature increases, so the dissolved gases in your cell can start to boil. And when they burst, that causes damage to your cell. So which means to say, if you want to scan, let's say the baby, right, where the cells are still dividing and growing, we cannot afford to damage the cell. So we cannot use high frequency, so we have to use low frequency. Because low frequency ultrasound doesn't get absorbed as much. And if it doesn't get absorbed as much, that means it suffers from less attenuation. So that means even the intensity you can decrease. You don't have to use a high intensity. If you use high frequency, more is absorbed, so you must increase the intensity, otherwise you cannot reach until the end. But low frequency, less absorbed, so you can even reduce the intensity. So the amount absorbed by the body is very little. So it will cause very little damage to the cells. But will there be still damage? We won't know, but there is a small chance. Which is why in developed countries, right, where they are more aware of the side effects of ultrasound, they don't encourage pregnant ladies to go for ultrasound all the time. Whereas in Malaysia, every time you go to have a checkup, right, if you're pregnant, he will always ask you to do an ultrasound. but it's not encouraged in other developed countries because of the risk of damage to the cells. So it's not completely safe, ultrasound. But the downside is because they're using low frequency, the what they call it, the resolution is very low. That's why you cannot see very clearly. You understand? So you must know the advantages and disadvantages of ultrasound.
Then is there any alternative?